everybody, and welcome to Echo Live, coming to you from the Michigan Science Center's Echo Distance Learning Studio. We are still closed to the public, but we are offering these free programs every single day so that you guys can get some science content while you are at home on your couch, chilling out. We're so happy that you chose to join us again for today's edition of Echo Live, where we are going to talk all about combustion reactions. On our very first day of Echo Live, we did talk about a little bit of combustion using our flame salts that we've brought with us. Now, our flame salts were an example of a fuel. If you remember back to our first program, we actually talked about something called the fire triangle. So go ahead and show me your triangle if you're at home and think about how many sides a triangle has. It has 3 sides. So we'll be talking about the 3 ingredients that we need in order to have a combustion reaction. The first one is fuel. Now, we saw our flame salts the other day, but we'll take another closer look at those fuels since we've also got some other types of metals that we can use today. So the 3 flame salts that we've talked about so far are copper, lithium, and strontium. We talked about how these different metals make great fuels because they burn at different temperatures and they create different wavelengths of light when they go through that combustion reaction. This is a great example of a fuel, but these metals are not the only ones that we could use. Before we get started with any of our combustion today, first a note on safety. Now I'm wearing my lab coat here to protect my arms and my clothing. I'll put on my safety goggles right now to protect my eyes, and then I'll also be using our pair of handy dandy safety gloves all throughout the program to make sure we are staying extra safe. This is a great time to practice using the chat feature as well. So while we go back through our flame salts, go ahead and tell me in the chat where you're watching from. Tell me what grade you're in if you are a student that's at home watching one of these programs, so that we know who's watching, we know who we can talk to throughout the program. Now we'll start with using our flame salts. For this, we'll need our Bunsen burner, which runs off of a butane fuel. That's another great example of fuel, the first part of our fire triangle. Now, if we turn on our butane torch, we'll notice that it's a little bit difficult to see just because of the light inside this room, but today I'm actually going to be able to turn off the lights. And so today we're going to turn off the lights and we'll get a closer look at this flame. The flame is blue right now. You can see it right on camera. Butane burns blue, but we said as we use different fuels, we can actually see different colored flames as well. So our lithium, if you remember correctly, was kind of this nice hot pink kind of color. Our strontium was this very noticeable reddish orange. We said that strontium is most commonly found in road flares that you might have seen on the side of the road. And then copper, if you remember correctly, is our last metal salt. And this one burns a nice bright green. So think about our Statue of Liberty, which also underwent an oxidation reaction, which is very, very similar to combustion. Now I have 2 other metals with me today to show different effects that go through our combustion reaction. The first one is magnesium. Now we use different types of metals in order to color fireworks. So we color fireworks by adding copper if we want green, lithium if we want pink, strontium if we want orange. But if we want to make fireworks bright enough to see them for miles and miles around, we have to add magnesium. Magnesium burns extremely, extremely bright. So we'll go ahead and relight my butane torch, which went out here, and then we'll be burning a piece of magnesium. Now, thankfully, over the camera, this is one time where you guys actually can look directly at this magnesium flame. Normally, when we do this show here at the Science Center, we have to ask people to look away because it burns so bright that it could actually damage your eyesight, just like you're told never to look directly at the light from the sun. So we've got a small piece of magnesium, kind of silvery in color, and this is going to burn extremely brightly when we put it through our Bunsen burner flame. Here it goes. Wow, that is extremely bright. So that is how they make fireworks bright enough that we can see them even though they're thousands of feet up in the air. The very last metal that we'll be adding to our Bunsen burner flame here is something called iron. I have some iron filings or kind of shavings inside this pepper shaker, which we can actually shake through our flame here. And then you can tell me in the comments, what does this remind you of? Now, this might look familiar. We talked a little bit about fireworks already. So if you are thinking that this looks like sparklers, you're exactly right. They coat sparklers with iron filings in order to give them that kind of dancing, kind of fun, sparkling effect. Now, this is fuel, right? So fuel is something that a combustion reaction needs. Now, we can flip our lights back on really quickly here. We'll turn off our Bunsen burner for just a moment since we won't need it for our next demonstration, because we're going to talk about the importance of heat and why we need heat in order to have a combustion reaction. I'm sure if we think about fire, there's really no such thing as a cold fire. So combustion needs heat in order to take place. It's actually one of those ingredients. So we'll actually be using this solution here. So solution means that it's at least two things mixed together. This is a solution of ethanol, which is an alcohol which is highly flammable, mixed with a little bit of water. For this demonstration, we're going to be doing something that you are not allowed to try at home, not just because it's related to fire, but because we'll be attempting to burn some US currency. Now, we know that that's against the law, but if you're doing it for science, you kind of get a free pass. At least I think so. So we'll go ahead and we're going to drop our dollar down inside our ethanol solution. So a mixture of ethanol and water. You might know that dollar bills or paper currency here in the US is printed on cotton. And cotton is very, very absorbent. So this dollar is absorbing that ethanol and that water at the same time. Now, we'll pull out our dollar and we'll let just a little bit of that excess fuel drip off. And then we'll hit our lights one more time. And then we will light this dollar on fire. Here it goes. And it's burning. But you'll notice that it pretty quickly goes out. We're still left with a dollar bill. And even though it was just on fire, this dollar bill is not hot at all. It's actually pretty cold to the touch. That's because of the water that we poured inside our ethanol solution. So that water is an insulator. An insulator is something that doesn't really allow things to change temperature by very much. You can think of our thermos that we talked about with our liquid nitrogen. That's great for insulation because it doesn't allow for a lot of transfer of heat. This water does the same thing. Since our dollar bill was protected by that water or insulated by it, it actually couldn't get hot enough to burn. Thus, we were missing a piece of our fire triangle and we did not have a combustion reaction. Now, heat is a really important ingredient to fire, but heat can also be used in order to start a fire. Now, the easiest way I know to produce heat, even without any of the equipment that I have on my table, is by creating friction. If you're at home and you'd like to try an experiment with me, go ahead and start rubbing your hands back and forth very, very quickly. The faster you rub your hands, the more friction you're creating, and that force will actually generate friction and heat. So your hands start to feel very warm. Now, thankfully, this is a very safe amount of friction. We couldn't possibly create enough friction with our bare hands in order to start a fire. But if we want to do that, we can use these two rusty cannonballs that I brought with me today. Now, this is going to be a pretty important combination of many factors. So we'll actually be using mechanical energy in order to create heat. We're going to strike the two cannonballs together, and when the force of them hitting each other, it has to transfer somewhere. And so we actually generate heat. And at the same time, we'll have a transfer of the oxygen from the rust on this cannonball to the aluminum that's covering the other cannonball, creating a thermite reaction. Thermite reactions burn at thousands of degrees. They're very, very hot. And so for this one, it's really important that I put on my safety gloves. And we'll be creating that thermite reaction right here in my hands. Here we go. We can see sparks flying across my studio. Let's try to take a closer look by zooming in just a little bit on the table. See if I can aim down there. So this thermite reaction, like we said, this is used for welding metals together. This version of it happens extremely quickly and goes out as soon as our mechanical energy is transferred. So let's see that again. That is the importance of heat in a combustion reaction. Now, we talked a little bit about another part of the fire triangle earlier, and so we can actually bring my lights back up for this one because it'll be pretty bright on its own. For this, we'll be talking about the importance of oxygen. Again, oxygen is something important for us breathing here on Earth as well. So everyone take a deep breath in and breathe out. Now, I'm sure that there's oxygen in the air all around us. Otherwise, it'd probably be laying on the floor. So we have oxygen all around us. So for this next reaction, we'll be adding a little bit of a very flammable fuel called lycopodium, which grows from a moss plant in the Upper Peninsula. We'll add just a little bit, since it's so highly flammable, to this watch glass. And then we'll use our lighter as our source of heat. And we just said that there's oxygen in the air all around us. So we've got all three pieces of our fire triangle combined with a very, very flammable fuel. We'll take a nice close look down at the table here and zoom in even further. I might need to put on my other gloves so that we get a close enough look. All right, so we've got our lycopodium, which is this yellow powder, here on our watch glass. And we'll combine our three parts of our fire triangle in 3, 2, 1. Now, even on camera, you can see that we've definitely had some combustion taking place. I can smell that it's a little bit burnt, and you guys can see on camera that we've actually toasted the top, almost like roasting a marshmallow. So definitely at least a small amount of combustion has taken place. But I said that this fuel is highly, highly flammable, but it didn't really ignite very well. That's because of the importance of having oxygen involved in our combustion reaction. Now, this lycopodium is an extremely fine powder, almost like powdered sugar. It's actually so fine that when it sits on a flat surface like our watch glass, it doesn't allow for enough oxygen to get around and underneath all of those molecules of lycopodium in order for all of it to go through a combustion reaction at once. If we want to add more oxygen into this equation, we have to use another device that I've got here on my table. That device is this lighter that has a straw attached to it. So let me zoom out for this one. And we'll be actually blowing air, my own oxygen source from my mouth, through this straw, pushing our lycopodium into the air, creating a giant fireball. So we'll go ahead and we're going to load up the lycopodium into the flame side of the straw. That way I can put a good amount of distance between my mouth and the flame. Really load it in there. All right, so now this time we're combining our fuel, which is lycopodium, our source of heat from the lighter, and the oxygen that's in the air all around us, combined with the air from my breath, and we will be having another combustion reaction in 3. Should have tested my lighter first. There it goes. 3, 2, 1. That's creating a pretty sweet fireball. Now, I have somewhat of a grand finale for everyone at home, another one of those loud kabooms that we're going to create during our show, but this is a great time to pause for any questions that you guys might have. If you do have any questions about the 3 parts of the fire triangle that we've discussed so far, or questions about our experiments, go ahead and type those in the chat feature. I'd love to answer some before we get to our very last demonstration of the day. During this time, we can also take a minute to thank some of our sponsors of the Michigan Science Center. They are the reason that we're able to provide these programs. Even while we're closed, they're the reason that we can provide these programs to you guys at home for free. We love providing our Echo Live programs for you guys. So big thank you again to the DTE Energy Foundation, along with the Michigan Science Center's other sponsors. Let's check for some questions here. See a question. So I have a question for why did it light on fire? I think you're talking about the lycopodium. Now, the top of the lycopodium burned on the watch glass because there's oxygen molecules that are touching it, that are interacting with the reaction. But only the top can burn. The ones underneath on the bottom side were protected by the other lycopodium molecules that were blocking the oxygen from the reaction. If you've ever snuffed out a candle before, you know that if you remove oxygen from the equation, the fire goes out. So this reaction actually couldn't even start up if we didn't have any oxygen involved. And so when we pushed it through the lighter, we exposed all those molecules to oxygen and allowed them to burn. See a question, do I ever get nervous? Not normally. I will say that when we try something new, we always do it with safety training. We always make sure that we have our fire extinguisher handy just in case we might need it. We've never had to use it, but it's always here just so we have that extra level of safety. So even though it can be a little bit intimidating to try new things, as long as you go into it prepared and you're following a procedure that someone has set that you know is safe, and you've got all of your safety equipment handy, there's no reason to be nervous. What was that powder? Again, this was lycopodium, and we buy it from a science industry source, but this lycopodium is actually a product of a moss plant from the Upper Peninsula. So it's actually organic matter, and organic materials make great fuels. See, a great question. What were the 3 parts of the fire triangle? If you remember them at home, say them with me right now. They are fuel, heat, and oxygen. See a question. Where would you find lycopodium? Again, we bought it from a science industry supply, but if you look up online, you might be able to figure out what spore it actually grows from or what moss it comes from. Where did you go to school to study science? I'd love to answer that question. I actually went to school at Wayne State, just across the street. So proud Wayne State alumni. I actually studied science there and then started working here while I was in college. Are there any home experiments you could try at home? Not involving fire, but we do have lots of other chemistry reactions that you guys can try using safe at-home materials. We'll be posting those on our Facebook page as well. We'll have some video links for you guys to try. We'll have some activity guides. And so we'd love for you to try out the activities. Let us know how they go. Share your results with us on Facebook or on Instagram because we'd love to know how your science is going at home, and we'd love to know how else we can help. Ooh, all right. So I see a really great question, and I think it's probably time that I answer it. See, what is this water bottle sitting in this container for? So I have this water bottle for part of our grand finale. So if we're going to do our grand finale, I do need to clear just a little bit of space on my table here because this one's a little bit messy, but it is my favorite combustion reaction that I know how to do. This combustion reaction we call our carbide cannon. Now, we normally call this show KABOOM-istry because we like to make things go kaboom. What else is the point of combustion reactions, right? Just kidding. There's lots of points to combustion reactions besides lighting things on fire and making things go boom. But this one is really, really fun. So we'll have to combine a few ingredients inside this empty coffee canister if we're going to make this into a cannon. Now, the first thing we'll need is actually water. Now, we talked about water when we did our dollar burn. We said that it is an insulator and it actually prevents fire from happening. But in this case, we need this water to generate our source of fuel. So just a little bit of water in the bottom, and on its own, I could try to light this on fire. Just isn't going to happen because water is not flammable. If we want to generate a fuel, we have to add our next ingredient, which is this calcium carbide. Now, calcium carbide looks like a smelly gray rock. It's another one of those materials that we've bought from a scientific supply company. It's not something that you can find at the grocery store, but when it does mix in water, it starts to create a fuel. It starts to create acetylene gas. Now, for this one, I am going to need stepped on my strontium bottle here. And I'm also going to need my hearing protection. Our cannon is not going to be loud for those of you at home. If you're uncomfortable with loud noises, you can always turn down your volume or cover up your ears. I'll go ahead and put on my very last piece of safety equipment here. We're going to use our calcium carbide to generate our fuel. There's already oxygen inside, and our source of heat is this tiny little spark lighter here. So we'll go ahead and we'll zoom in on the table, get a very up close view of our carbide cannon. Here we go with our carbide cannon. We've got our fuel generating, and we'll be launching it in 3, 2, 1. Ta-da! My favorite combustion reaction to share with you guys. Thank you so much again for joining us for today's version of Echo Live. We will be back on Monday with some more live science experiments, and we'll also be posting those experiments that you can try at home. We hope to see you again on Monday at 2:30 p.m. Eastern. We'll be answering more science questions and bringing you more science programming all week long. Thank you guys so much for joining, and have a great rest of your day.